What is Universal Flash Storage, UFS? Defining the high-speed standard. Universal Flash Storage, UFS, is the cutting-edge flash memory specification used primarily in high-end and mid-range mobile devices, such as smartphones, tablets, and advanced digital cameras. It serves as the phone's internal storage, housing everything from the operating system and apps to your photos and videos. The origin and purpose. Developed by the JEDEC Solid State Technology Association, UFS was designed to address the growing performance demands of modern mobile computing. Its core mission was to deliver higher data transfer speeds, improved reliability, and better power efficiency compared to its predecessor. The role of embedded UFS, eUFS. In a smartphone, UFS is typically found in an embedded form, often referred to as eUFS. This means the memory chip is permanently soldered directly onto the device's motherboard, creating a highly integrated and optimized storage solution. The core architectural advantage. The speed of UFS comes from two major architectural improvements that set it apart from older standards like eMMC, Embedded Multimedia Card. Full duplex versus half duplex. The most significant difference is the use of a serial interface with full duplex communication. This means UFS can read data and write data to the memory simultaneously, just like talking and listening on a phone call at the same time. The older eMMC standard, by contrast, uses a half-duplex, parallel interface, meaning it can only do one task, read or write, at a time. Command queuing for efficiency. UFS also adopts command queuing, CQ, a feature borrowed from PC-based solid-state drives, SSDs. CQ allows the operating system, OS, to send multiple commands to the storage chip at once, enabling the chip's controller to reorder and execute them in the most efficient sequence possible. This dramatically reduces latency and speeds up demanding operations like opening heavy apps or using a burst-shot camera. The generational leap, UFS 3.1 to 4.0. UFS is constantly evolving, with each new version offering substantial performance gains. UFS 3.1, the 5G standard. UFS 3.1 represented a major step forward, delivering sequential read speeds of up to 2100 MB per second and write speeds of around 1200 MB per second. It introduced key features like write booster, using a small, fast cache for quick write bursts, and deep sleep, a low-power mode, making it the standard for early 5G flagship phones. UFS 4.0, doubling down on speed and efficiency. The latest generation, UFS 4.0, nearly doubles the speed of its predecessor, pushing sequential read speeds up to 4200 MB per second and write speeds to 2800 MB per second. Crucially, it achieves this while being 46% more power efficient. This massive leap is critical for handling tasks like 8K video recording, immersive VR experiences, and rapid data processing for advanced on-device AI. For real-world impact on performance. The speed differences provided by UFS translate directly into a noticeable enhancement of the user experience. You'll see faster app loading times, quicker phone boot ups, and seamless multitasking when jumping between numerous applications. UFS is no longer just a luxury specification, it is a foundational component required to unlock the full potential of modern, high-performance smartphones.